Base times height. Now, again, get out of middle school. Get out of middle school. Base doesn't automatically equal bottom. Take a look. The base will be wherever the height is drawn to. All right, so let's say I draw the height here. And again, height is another name for altitude, so it's going to form a right angle on the opposite side coming from a vertice. So here's my height. Notice the side that height is drawn to. That's what I'm going to be considered my base in the formula. So please get out of that middle school mindset that base equals bottom. It's wherever the height is drawn to. That is your base. Base times height. Triangle. I think you've dealt with that before. Triangle. Going. Atticus.
Base times height divided by 2.
Yep, base times height divided by 2. I like to write it 1/2 base times height, but you are certainly correct when you say base times height divided by 2. Same thing. Same exact thing. Base does not equal bottom. It is wherever your perpendicular height is drawn to. So say I go from this vertice here, and we'll just pretend that's perpendicular. There's my height. So using the formula, I would use this length as the base. Because remind me, I just drew in 1 out of how many heights I could have drawn in this triangle. How many could I have drawn in? There's 1 out of how many? 3. 1 from each vertice. Wherever the height is drawn to, that's what I use for the base in the formula. Trapezoid, that's a mouthful, that formula. Anybody know that one? Here you go, ready? 1/2 the height times the base, the sum of the bases. I'm going to call it B1 and B2. In a trapezoid, you have a pair of sides that are parallel. In a trapezoid, you have a pair of sides that are parallel. Those are your bases. That's B1 and B2. Okay? The parallel sides are your bases, and then your height is the height we've been talking about, which is coming from a vertice perpendicular to the opposite side. There's your height. How about circle? Circle. Pi r squared. Yes. There is no diameter version. There is no diameter version. We just got done with circles, so r, what do you think r is? Radius length. There we go. All right. Your good old rectangle formula. That is basic. Length times width. Keeping with the base times height, you could also do base times height. All right. And, rhombus and kite. There's a new one for everyone. Rhombus and kite. Ready for this one? We'll do this tomorrow. 1/2 D1, D2. Okay, everyone think about a rhombus and a kite real quick. What parts in both of them start with a D? It could be, but it's all multiplication, so it doesn't matter what order you do them in. Diagonal length. There you go. Remember, there's 2 diagonals in a rhombus, 2 diagonals in a kite. However long they are, I multiply and then divide by 2. So diagonal length. All right. So there are your 6 formulas. One drawback about this unit, you are not given these formulas. Okay, there's not a formula sheet for them. You are responsible for those formulas on your own. All right, any questions here or in class? Today, parallelogram triangle, that's our focus. So why don't we start with the parallelogram right now? There we go. All right, perimeter and area. That's going to be a common question. Not only give me area, but also give me perimeter. So let's start with the perimeter of this parallelogram. We already know one side is 23. Guys, you know your parallelogram properties. What's got to be another side length? 23. Opposite sides are congruent. So I got 23 plus 23 plus, I don't know those other 2 opposite congruent sides. I know 23 and 23 because opposite sides are congruent, but I do not know the other two opposite sides. Can you give me any help how to find them? Here we go. Start calling on people. 2, 6. Up first, 12. And here we go. Lucas, how can I find Pythagorean theorem with 7 and 24 as part of that right triangle? A squared plus b squared equals c squared. Perfect. So I got 24 squared plus 7 squared equals c squared. I'll let you guys a second or two here to find c. Take your time. Seven, when you get it, let me know. St. John, when you have it, let me know.
C equals 25.
25. There's the other two opposite sides. So 25, 25. And we end up with a perimeter of 96. I've kind of threatened you, but I've never followed through on it in past units. This unit I will. Put your darn units on. Put units on if they have them, and you'll see why when we get to area. Put your units on. All right, you ready for area now? Area, base times height. Remember what we said. Height is always perpendicular to the base. Everything you need is already there. You just got to select the correct values that represent the base and the height here. The base is perpendicular to the height. The base has to be a part of the actual parallelogram. Okay, here we go. Sean, what's going to be considered the base and the height here?
Sorry, the base would be 23 and the height would be 24.
There we go. 23 is the base because the height, the perpendicular segment down to it, is 24. There it is. Any questions on why I didn't pick 7? All right, moving on. That's why you guys have your calculators today. 552 feet, but now we're doing area. Anybody know area?
Isn't feet squared?
Square units. Not the 552, it doesn't get squared, the units. All right, so that's why I'd like you to put units on now. Perimeter, it's just feet, and then area, I change it to square feet. Any questions here before I really start ramping it up? Here's why I love this unit, and you'll probably hate it, because we do have to review a few things from the previous 30 weeks we've had together, including 45, 45, 30, 60. We do have to remember those rules, because as you guys can take a look in parts A and B, those are the type of triangles we're going to work with, all right? So before I get into them, let's review our 45, 45, 90 rules, because I'm going to have to use those right away in part A. All right, anybody remember anything about the two legs? Right triangle, 45, 45. What do I know about the two legs? Omni, go. Legs are congruent. The sides across from the 45s are congruent. There you go. Anybody remember the rule now? How do I find the hypotenuse on a 45, 45, 90? Anybody remember that one? Ooh, dig deep, dig deep.
Is it the legs timed radical 2?
Oh, there we go. Leg times radical 2. Love it. Yep, whatever one of the legs are times radical 2. And then you guys will see in part B, we're going to move our attention to the 30, 60, 90 now. Now the legs aren't equal. The side across from 30 we call the shorter leg because it's across from the smaller angle. So now, how would I find the longer leg? That would be the side across from 60. Side across from 60, longer leg. Do you remember that one? Yep.
Short leg times radical 3.
Short leg times radical 3. There we go. Shorter leg times radical 3. That's a multiplication symbol there. And then how about the old hypotenuse here? How do we find the hypotenuse? Do you remember that rule? What's up, Sophia?
Isn't it double the shorter leg?
You got it. Shorter leg times 2. Good. There it is. Okay, little review there. All right, ready? Just the area, no perimeter, just the area of each of these two parallelograms. So remind ourselves, base times height. All right, we are not given the height here. We are not given the height. But real quick, what is the base I'm going to use here? What's the base length here that height is drawn to? 2, 1. Zach, what's the base length that height is drawn to?
9.
Whoa, is that the whole? Remember the parallelogram. That's not the whole side of the parallelogram. What's the whole side? 17, all right? So there's the base, 17 of the parallelogram, not the triangle. All right, somebody help me find the height. Notice the height is across from 45, and the 9 is across from 45. Put the two together, what's my height? Knowing my rules. 12, Lucas, going back to you. Also 9. Legs are congruent, so the height is also 9. Please stop me if you have any issues. 153 square yards. Going. Part B. Again, same thing. I don't know the height. I do not know the height. I'm slow here today. I can tell you what the height is drawn to, a base of how long? What's my base length here? 6. Caroline, what's my base length? 32. Good. So it's going to be 32 times something. 12. What type of leg is the 12? Is that shorter or longer? Shorter. It's across from the 30. What's the height? That'll be my longer leg or hypotenuse. Is the height the longer leg or the hypotenuse? Longer leg. So do the rule. I have 12 as the shorter. What would be my longer now using the rule? Boom! 25. Sabrina, what would be my longer leg?
12 radical 3.
Good job. 12 radical 3. I want to stop everyone right here. I know the directions say nearest tenth if necessary. Tonight it might say simplest radical form. So right now, let's pretend the directions say simplest radical form. You can multiply anything. Just because one has a radical 3 and the other doesn't, you can still multiply them. So if I asked for your final answer for simplest radical form, 32 times 12, which would give me, you guys are seeing, 384 radical 3. That would be your answer in simplest radical form if it asked tonight. You can multiply. Can you add them or subtract? No, but you can multiply them. All right, now let's follow the directions. Nearest tenth. Now 384 times radical 3 in your calculator. 665.1 square meters. Okay, 30, 60, 45, 45. Any issues if that comes up later on tonight? Going, questions? All right, there's going to be another issue coming up in a minute. Not right now, but in a minute. All right, let's find the perimeter and area of each shaded region. All right, you guys see in part A, the shaded regions are triangle, right? All right, we'll start perimeter. Oh, nice. Look what I gave you guys. 19. I gave you 41. I just didn't give you the third side of that shaded triangle, did I? Oh, geez. Can I get your help trying to find that third side of the shaded region? How can I find that third side? Little help. 16. Nope, not here. 5. Hayden, give me a little help. How can I find that third side?
We can use Pythag.
Pythag, using 30 and 27 on the other triangle. Perfect. So I got 30 squared plus 27 squared equals c squared. Now you guys will notice something. As you start doing your calculations, you'll get c squared, keep going, to be 1,629. And then you'll take the square root in your calculator and find that it's not a perfect square. Do you round that number in your calculator right now? No! We're not done with the darn problem. You keep it right there, please. Don't round on your own until the end. So all you're going to do is write in your calculator, take that decimal and add 41, add 19. Do not round until the end. That'll be something over and over I'm going to be a broken record about. Don't round to the end in this unit. Now you can round after you add 19 and 41 to it. Nearest hundredth, 2 decimal places, hundredth. 100.36. Oh, I almost put square there. No, just 100.36 inches. Excuse me. Okay. What about area? Ooh, all right. How many of you are just doing BH right now? I know we've done parallelograms. It's a triangle. It's a triangle. Get your mind right. Get your mind right. 1/2 base times height. You guys have everything you need right now. You have everything you need. You just got to pick out what's the base and what's the height now. The base should always be a full side of the triangle we're finding the area for. Talk to me. What's base and height for this one? Oh, 8. Ryan, what do you got? Base and height.
46. I'm at 19.
19 base with a height of what?
30.
30. Good. 30 is the perpendicular segment drawn to the base of that triangle of, what do we say again? 19. 1/2 base 19, height 30. Good, Ryan.
Why is it 19?
What's that?
Why is it
27 is not a side in that triangle, so it can't be the base. If you were finding the area of this white triangle here, yes, it would be 1/2 30 times 27.
I'm up by 41.
Why 41? There's no height drawn to 41 though.
Is the height drawn?
Here's the height. Remember, vertice perpendicular to the opposite side, which would be 19 here.
Oh, so it's whichever side is perpendicular.
Yes, correct. Remember, the height's got to come from a vertice. And what are you guys looking at there? 285. Look good? Square inches. Units, units, units. We're all good? All right, let's do it. You better buckle up now. Buckle up for this one. This is a parallelogram. Okay, I'm letting you know it's a parallelogram, the shaded region. All right, that's a parallelogram. Perimeter, 12, 12, uh-oh, uh-oh. Oh boy, oh yeah. How about this? Can't use your 30-60 rules, can you? Or 45-45. Oh boy. Still got to find that side though. Ooh, I gave you 35 in there and that 4 yards. What can we've done this year, what can we use, even though it's not 30-60, 45-45, it's still a right triangle. No Pythag, because you don't know the second side. There's still SOHCAHTOA. Yep, good job, Audrey. Yep, sine, cosine, tangent. Oh, look at all the review we're doing, yes. All right, so I need to find this side x. All right, let me write it out. You guys have it over there, but kids at home don't. So SOHCAHTOA. Right triangles only. All right, just a reminder how we use SOHCAHTOA. We go from the acute angle, 35. How do you classify what the 4 is to the 35? You have 3 choices. It's either opposite, hypotenuse, or adjacent to it. It's opposite, the 35. And what about x, the side we're finding? That is hypotenuse. So if you have O and H, which one of these 3 ratios am I allowed to use? If you have O and H, which one of the three?
Sine.
What's the S? Oh boy.
Sine.
Sine, yes. Ready? Sine of your angle, 35, equals, what's sine equal to?
4 over x.
Opposite 4 over hypotenuse x. Okay, solving these. Back in the day, I had you guys put this over 1 and do what? Good, cross multiply. Quickly, before you start punching numbers in your calculator, make sure you're in 35 degree mode. 35 degree mode. Make sure you're in degree mode. Again, to get to degree mode, top of your calculator to the right of the second button, you have a mode button. All right. I have to put it in degrees myself. Make sure degrees, enter, make sure it's highlighted now. And now you can go back. So we cross multiply. What am I looking at there? Sine of 35 times x equals 4. How are you getting the x by itself? Divide both sides by the sine of 35. So I would use a fraction template, 4 divided by sine of 35. I'll do it with you. 4 over sine 35. Gonna round that?
No.
Nope. What do you have to do with it though? Add it again, right? Because that's both sides of the parallelogram are 6.9737. So plus that again, plus 12 plus 12. And that'll give you the perimeter. So I'm just going to take this right here and plug it in here and here, that decimal. And check out your rounding directions, still nearest 100, 37.95 yards. All good? You all right, Audrey? Anybody at home questions? Because we still got to do area. And that's going to bring up a different problem. Parallelogram, base times height. What would I be used as my base here? 12 or the decimal I just found in my calculator? Look at where the height is in this diagram. Look at where it's drawn to. What should I use? 12 or the number I just used in the calculator? Which one's your base here? 13. Sophia, which one's the base here? 12. Good. So I'm going to say 12 times, what's the problem, guys? I don't know the height, right? That's missing again. Here's your height, everyone. Here's the height. I don't know it. All right, a couple ways we could find it, though. A couple ways. You just found this hypotenuse, right? You found that hypotenuse. You could do Pythag, right? You could use Pythag. Or, here's what I'm going to do just to keep practicing using sine, cosine, tangent. Ready? 4 is still opposite. What's the height now become? That is the what side to 35? Adjacent. What could I use now of the three ratios if I have O and A? What's the T stand for?
Tangent.
Tangent. Tangent now. Again, if you want to use Pythag to find it, that's fine. I'm going to use tangent just to practice. So tangent of 35 equals opposite is still 4. Adjacent is your height, H. Don't round in your calculator, right? Don't round. Tangent of 35 times the height equals 4. And then divide both sides by the tangent of 35. Woo. Now you know what I mean by it's not basic. Can't even read it. 68.55 square yards. Whew. So wow, guys, 30, 60, 45, 45. Sine, cosine, tangent. What else are we going to end up seeing again? Questions here? We ready to end class on good old DeAndre? Ready for DeAndre? He's a gardener. He's a landscaper. Pretty nice, huh? He's a landscaper. He wants to mulch his beautiful garden here. He knows one bag covers 12 square feet. How many bags is he going to need? All right, well, I got a problem here. Can you help me? We've done perimeter and we've done area today. How am I going to know which one? Because it doesn't come out and say. Is there anything in the problem that says, hey, you better find me this instead? What's up back there, Ellie?
It says square feet.
So that means I got to find the what?
Area.
There you go. So it says, hey, a bag covers 12 square feet. And I know anytime the units are squared, I need to figure out what the area is. That's coming from the area. All right, no big deal. It's a triangle. 1/2 base times height from today. Let me turn it over to you guys. There's a lot of numbers up there I threw at you, but only 2 represent the base and the height. Lucas, one more time. Base and height here.
7 and 9.
Yep, 9's the height, drawn perpendicular to the base of 7. There it is. There you go. Calculate. Area of his garden, 31.5 square feet. This is where you guys just start going off the rails. Crazy. I don't know if I divide or if I multiply by 12. I can never figure that out if I divide or multiply. Well, don't make it a 50-50 guess. Let's talk some mathematics here. You got 31.5 square feet. Every bag covers 12. Takes care of 12 square feet. Multiply or divide? Multiply or divide here? Divide, divide, divide. Divide by 12. All right, let's drop the math for a second and let's have a nice little life lesson with Mr. Carlino right now. Life lesson, all right? You don't learn all geometry in here. You get a couple life lessons. We're going to go to Lowe's right now, okay? We're going to go to Lowe's. We walk into Lowe's. We find an employee. Can I help you guys? Yeah, we're going to buy some mulch. All right, no problem. We got tons of different kinds. How can I help you? How many bags do you need? Well, we're going to need 2.625 bags. And he's just going to stare at us. Or she. It's going to stare at us. Okay? You can't buy 0.625 bags. I hate to break it to everybody if you've never been to if you've ever been outside. Okay? You can't buy that. All right? You do, even though it doesn't say it, yes, I need whole bags here. All right? I will never accept. You did not tell us in the directions to round to the nearest whole number. I don't need to. All right? I don't need to. If you're breathing, you know we have three bags, yes. All right, 3 bags. You cannot buy 0.625 bags of mulch. I'm sorry. 3 bags of mulch. All right? Everyone good? Life lessons with Mr. Carlino. Oh, now he's going to border his garden. That's cute. Now what do I need? Not the area. Perimeter time if I'm going to border it. And yeah, you're welcome. I gave you everything you need, right? What was it again? 23, 7, and 15. So his perimeter is going to be 45 feet. Great garden. So what do I do with the 45 feet and the 4 there? What should I be doing with the 45 feet and the 4? I am praying that everyone who has their hand up will tell me nothing. You don't do anything with the 45 and the 4. Don't tell me divide. You can't. You can't divide those. Anybody know why I can't divide them? Now, here we go. Omni?
Because one's in feet and one's in
You can't have different units when you do the calculations. I got 45 feet for the perimeter of the garden, but these stones are 4 inches each. Not going to fly. Not going to fly. Woo! It's going to be a rough one, this unit here. Detail, detail, detail. Change the feet into inches, multiply by 12. Or I guess you could turn the 4 inches into feet, up to you. I have 540 inches of garden. Now what can I do to find the number of stones? Now what can I do with the 540 and the 4? Divide, yes. And just a heads up, it's not always division. Somebody asked me, and I'll get to that in a second. Let me finish this. 135 stones. Somebody asked me in my first period class, well, what would be an instance where we multiply then? All right, here's a problem where you would multiply. Let's say instead of a garden, this was a parking lot. I know, triangular parking, whatever. It's a parking lot. And it would cost me 50 cents per square foot to pave it. That's how many square feet I have. It cost me 50 cents per square foot. Now I would multiply. Okay, so just don't get in the mindset it's divide every time. All right, let's see what you guys are going to do on the homework tonight. No work shown for me. All right, what are you going to bring to the table tomorrow? Hot garbage, which equals hot garbage test scores, or great things like most of you have been showing me. Have a great night. Behave. See you tomorrow.